Now, finally, I'm going to show you how to solve the same problem, the RMC, using a solver. The key here is to set it up correctly and properly. These numbers out of there. Sorry, I still have some numbers from example. We don't need those. Okay. So as I was saying, the key here is the setup. The setup is rather difficult, but once you do it, you can use it over and over and over again. Most of your problems are going to come from not having a proper setup in your solver, in your Excel. So these are the components. First of all, you're going to have your coefficients up here. Again, if you follow my instructions, and you should be okay. So for coefficients, you're going to have the coefficient of fuel, which is 40, and the coefficient of solvent, which is 30. You can see them there on the left side. Okay? Now, these two are empty. There's nothing in those cells. Leave them empty. The next one is your objective solution. We call it Z. Now, this one has a funky formula. Is the sum product. So the sum product, what it does, it takes a series of cells and it sums them. How to explain? It takes it takes two series of cells, it multiplies them and adds them together. So what you see here is, all right. What this is saying is take the top and multiply it by the cell below and add it to the multiplication of the next one multiplied by the one below that one. So it will be 40 multiplied by whatever is going to go here in a moment, plus 30 times whatever goes in this cell. That's how it looks, the sum product. And the way you do it, actually, let me delete it, and I'll show you how I build it. Sum product. And then my first array is the top line, okay, then comma, and my second array is the one below. If there was a third array, you will add it, but in this case, there are only two, and we'll always work with two. So close the parentheses, okay? It should be 0 because there's nothing there. Now notice, if you want to play around to test it, if you put a 1 there, you see what happened? 40 times 1 plus 30 times 0. Well, there's a 0 there, right? Equals 40. If you put a 1 there, well, you know the answer, right? It's going to be 70. All right, you see how that works? Put a 2, that's 80 plus 30, and so on and so forth. All right, so delete these numbers. That should come back to 0. This part in the middle, this doesn't do anything. This is just setting up the problem so you know what you're doing. So my first constraint, C1, was 0.4 times F plus 0.5 times S. Now notice how I'm lining them up with the F. So the F's are going to go here and the S's are going to be here. Okay. And that is less or equal to 20. The next one is 0F 0.2 S less or equal to 5. The next one is going to be 0.6 plus 0.3 times S less or equal to 21. And then my final two, F greater or equal to 0 and S greater than or equal to 0 as well. You see how we put a 1 in there? So that's 1 times F plus S times 0. So that will be a 0. So it will be F greater or equal to 0. You are always going to have these two constraints at the bottom. If you have more materials, you'll have more constraints. Okay, next. Now this one is going to have some crazy math, some crazy formulas, okay? Notice, it's the same as the one above, constraints 1 through 5, constraints 1 through 5, left-hand side, right-hand side, okay? This is the left-hand side, this is the right-hand side. If you want to take care of the right-hand side right now, it's pretty easy because it's going to be just that. That's the right-hand side, 25, 21, 0, and 0. Now, on this side, this is also the sum product, you see what's going on there? Of each constraint times, this is incorrect. There you go. See, I had them all incorrect. Let me fix them up quickly. I must have moved something in. Okay, perfect. Oh, they should all be 0 when you start. That's how I knew there was something wrong with it. So what you're doing is you're multiplying each of these left-hand side constraints by the factor in the final solution, which you don't know yet, is a blank, and then add them together, okay? And you do that in each of them. Just make sure that, let me see how, okay. As you can see, it changes. Okay, make sure that for constraint 3, you are multiplying constraint 3. And for constraint 4, you're multiplying constraint 4. Okay, that is very, it happens all the time. You add another line somewhere and you forget to adjust it. Okay, great. Now here's a little trick in the form. You see the dollar signs? When you put a dollar signs in a cell like that in front of a letter, in front of a field or a row, it fixes it. It doesn't make it move. It doesn't allow it to move if you copy and paste. That's how I did it. Okay, this is the proper setup. You got the right formulas in the right places. Now you go to solver. So you go to data, up here, solver, over here. All right. You're going to set objective Z, F6, you see it there? I just selected F6. To what? To the max. Oh, sorry. Of course not. I clicked too fast. To max. By changing these two variables, which are unknown right now, given the following constraints, subject to the following constraints. So you're going to hit add. Now, here's a little trick. These three constraints up here, they all have the same sign. So you can group them into a single constraint because they all have the same sign. So I'm going to do that. So I'm saying these three left-hand sides are less or equal to these right-hand sides. Notice I'm not picking the bottom two because those two have a different sign. They have to go apart. You have to build them up, separately. Click OK. Now I'm going to add for those final two. Oh, sorry, I clicked on the wrong place. Sorry. These two are greater or equal to that. Okay? One final step. Make sure you check this. You see this? Make sure you check that. Okay? That does the same thing as the two last constraints, but it's a good way, in case you forgot to add them at the top, you can add them here automatically. I put them in both places so as not to forget, okay? But it means exactly the same thing. And then you change this to simplex LP. Don't do the nonlinear, just do a simple LP. Hit solve. Look what happens. Nothing because I messed something up. No, it's still running it. Oh, it's running it. There you go. It just finished. It found the solution. The optimal solution is 2520, which we also discovered by doing it graphically. That's the answer. It's going to ask you whether you want to keep. Yes, you want to keep the solution, or you can restore the original values, and it will just erase them. I'm just going to keep them for so you can see them. Okay, and that's it. That's how you do it using Solver.